Yes. Yeah, that's the scary part. So the role of science and and scientists, right? Because they go together in marine science. I think we could even think of this in society or in policy, or you can read this in many ways. So our plan is for me to share a few slides with you, and then Jess will come and also share a few slides. We hope to do this and I didn't tell you this, we hope to do this in half an hour, the two of us combined. So we have 15 minutes to hear from you because this is really a collective. So the role of science, usually, as my reading tells me, there are two key ways you can get into this discussion. One is how you can contribute to policies that relate to science, because there's a big group in the US in particular, the AAAS. They are really looking at how they can influence science policy related to science. But I don't think this is what we're talking about here. We're more interested in science for marine policy, if you like. So how can science be used to improve policies that can benefit from scientific understanding? But that's the two general goals. And there are all sorts of strategies to try to achieve this. The first one is, hey, you're going to provide information. So your goal is educating policy makers about science, okay? So you just say, and I think Beth mentioned this right away in the morning. You as a scientist, a key role for you, I'm not going to say that's the only role. The key role is that you want to provide scientific information, inform people, policy makers and the population actually. But then there's the second one actually, where a scientist can choose to champion particular policy outcomes based on their research or research of their colleagues by using persuasive arguments, political pressure, or positive incentive to achieve particular policy goals. This is controversial. There are many scientists who believe that what you really do and only do as a scientist is the first one, provide information and go to sleep. You are an objective person, you just provide information, right? But then there are actually more and more scientists that say, hey, we're part of the society. We find out something, we're going to just publish and are happy we take it out to the population. And then advocacy comes in and gets complicated. So let's see how this plays out. Now, the pursuit of objectivity is the cornerstone of science. So your real aim as a scientist is to, no matter where you are coming from, you want to analyze your data, you want to do your policy, your modeling, whatever analysis you do, you want it to be objective, okay? You really have to follow the protocol of science. You do not fake your data. You do not say things that your data don't tell you, your analysis don't tell you. That is fundamental, okay? So science generates knowledge and understanding by attempting to eliminate potential sources of bias, and different disciplines do this differently. Some will use controlled experiments, that's the easy one, the hardcore science will do that. This pursuit of objectivity increases your credibility, or the credibility of scientific advances, and actually makes it possible for society to be willing to adopt what you find, okay? If you don't have credibility, really, you don't go too far in the long term. You might be able to deceive some people, a few people for some time, but in the long run, you go there, really. So, honesty, transparency, telling people what you know and what you don't know, your assumptions is crucial. So that is... Now, making societal choices, this is actually different from doing science, right? So this society decided, and society can be at the politics level, government level, and far all the way to local communities and so on. How do they usually make decisions? It involves both using objective information, most policy makers, sensible ones, will want to have objective information to start with, right? I was at the British House of Lords. There was G20 leaders who were there, and they invited a number of us, 4 scientists, to come in and tell us something we didn't know from our science. And somebody in the audience asked a question to the politician. He said, "We know your work is hard. So do you want us to tell you what might be possible for you to implement from our science," right? So you find out something. For example, you find out subsidies are bad, but you know it's difficult for scientists to push it through. So you say maybe they are not bad, or they can be good or bad, right? Should we do that? And Mr. Gardiner is a member of parliament. He got really, I've never seen someone being pissed off like that. He said, "Look here, you're a scientist. If you are not going to tell me what your science tell you, don't shut up. I don't want to hear from you. Don't do the politics for me. Tell me what you find, and it's my job to take that information and find a way to make it happen, right? That is my job." So that is crucial, objective information. So what are the possible options, what benefits and risks may be associated with those options, and how are the benefits distributed? We can do that, especially as interdisciplinary people. Then, but the society doesn't just use only that. When they get that, then they also do subjective value judgments, you know. Why they then, and this is a politician's job actually, really. Provide that, tell them. And that is why we have tenure at university, so you can be free to talk what you see. Whether society likes it or not, that's not your business. Yeah, at the time they may even go after you, but that's okay. I mean, if it's really the fact you find, with time it will show up. So this means that people can agree on a common set of facts relating to the societal challenge, but disagree on appropriate policy responses, right? We can all agree climate change is happening, but what to do? I mean, I don't know. It depends who you are talking to. Do we all agree it's happening? Some don't, actually. Some say it's China that exported it to the world. But in general, you can agree on a fact, and the question of what to do will then be determined by judgment and politics and all. Now, there is a big objectivity debate here, and some argue that scientists should maintain their objectivity by avoiding civic engagement altogether, or by focusing exclusively on providing information relevant to civic discussions. Beth, I think that's what you said, and I think that's at least almost fully your position, right? As a scientist, and that is all right. This is the beauty, we have different views, right? And some of us will say, look, that's what I know I am supposed to do as a scientist, and that's what I do.
It's just that it's not, you don't run up and throw the science at them and then walk away.
You don't want to?
You don't deliver the science without interpretation or discussion. It's
Very
not,
good.
Here's the paper, you figure
Here
it
you
out.
go, yeah. So at least you should be able to, yeah, okay.
You do have to have that conversation, but I've just seen that it's been long-term self-defeating to be an advocate.
Oh yeah. No. That we agree. I mean, you don't become an advocate. So when you hear me talk about any policy thing, it's based on a paper either I or colleagues publish. It's always like that. And when I want to swim away and say my opinion, I let the journalists know. This is my opinion. This is my talking. It comes from whatever. But subsidies, I say, this is what we find. We know it can affect sustainability. And bam, okay? So that you can do. Other scientists argue that the membership in society confers a right or even a responsibility to engage more actively in civic discussions. So you can have the two views, and they should be able to live together, really. I mean, why not? And think of doctors. A doctor that finds out there is something that is negative to children, keeping quiet. I'm just a doctor. Come on. You should be on the roof telling society there's a problem. Mad cow disease, you remember that, right? So you almost have a responsibility. If you know that something is negative to society, please say it. Yes. I don't know. Okay. This guy, you see, this is why I agreed to be his co-supervisor, this guy. It's alluding to something, forget him. Yeah, you can get all sorts of questions. And I told them a story about how I got calls, and I said, what do I know about this, right? But maybe science is too slow. There might be consequences we'll know later, right? That we don't know. Yeah. Gosh.
He was so good. Yesterday he's like, I'm going to do this. No, I can't do it. He was so nervous.
No, this guy is never nervous. You don't know him. It's great. Yeah. Only I know. You gotta be careful a bit, okay? All right. So the difference between scientific debates and courtroom advocacy, and this is really what IMBeR was also alluding to. I keep coming to you, right? Because you made an important point right from the word go. And you think of, this is an example of a lawyer in a courtroom versus a scientist. You know, what lawyers do, they make the argument, whatever the argument that will let them win, that's what they make. But actually, scientists, you're not supposed to do that. That is advocacy. So in the courtroom, advocates make the strongest case on behalf of their client that they can possibly make. It isn't the lawyer's job to make the counter case. That falls on the other side. So if they know the fact, if it will help the other side, they won't say it in court, no way. And that's all right, that's their function in society. But as a scientist, in contrast, we rely on full and objective assessment of the evidence. Scientists have an obligation, it's actually your obligation to identify conflicting evidence, you know, expose weaknesses in your analysis and offer plausible alternative interpretations. That is science. So it's not only about what I find. That's why we always ask you to do a literature review first, know what is out there. When you come out, you know how to relate what you find with what is out there. So that's a big difference, okay? I got a question, we were in Paris and somebody said, why should a politician, and he was joking with me, he said, why should we trust scientists? Why should we? So I said, you are right, scientists are people. Some of us, or even the same person, we are all motivated by the same things in society. Money can corrupt scientists, so that I give you. But I tell you, scientists have a process. And what some politicians do and get away with, if we do it, we'll get slaughtered by our colleagues. That was what I said in the big room, right? So that's the thing. Think of politicians, you know what they say, and they walk away. My God. No names, okay? Oh, so then the policy process actually is a combination. It's a combination of courtroom advocacy. That's what politicians do. So if you think of the US, and you can take this to any country in the world, you have the two-party system, you have the Democrats and the Republicans. I tell you, most of the time, it doesn't matter whether you have the better argument. The one who is able to convince enough citizens to follow them carries the day, you know. But at the same time, the system is not purely on advocacy. There are a lot of institutional settings to provide objective information. The budget office, for example, the Congressional Budget Office, they are quite powerful. They're bipartisan, they try to be neutral. If you come with your healthcare policy, they evaluate and tell society how much it will cost, no matter what. Hmm? Yeah. Politicians can ignore, but at least they do their job. Why? Because politics and decisions are different. Scientists who engage with the policy process must decide their position, or where you stand, how you relate to this. Well, one of our former presidents at UBC, Stephen Du, is now actually the president of Cambridge after UBC. He's the first non-British to be president of Cambridge University. Amazing, Canadian, yeah. So when he became our president, he gave a talk and somebody asked him, UBC professors, are they allowed to do advocacy, or we only scientists? I say, you know what? At UBC, professors decide what to do with their time. If advocacy is what you want to do, just do it. Science advocacy, fine. If you don't want to touch anything, fine. We're a big tent, and I think that is really my position. And that is actually a positive, because nobody is 100% right, actually. So you drag yourself in the middle somehow, hopefully. And so, yeah, so this is something to, yeah? So I think I'm ready to hand over, right? Is that right? Yes. So that's just to get us a bit started, and then Jess will talk more related to oceans, actually.
I'm not going to use this one. I'll project to the back. Thank you, Rashid. I think I'm starting to notice a trend where my more senior colleagues present grand theoretical ideas, and I need more simplified stuff to cling to. So I start with a definition of governance, because I need these sort of stones in the ocean to guide my way. So, if we...
How long will you be doing this?
Yeah, give me a few years. So, sort of the go-to definition for governance that I'm familiar with at the natural resource management scale is the Bierman one, and more specifically focusing on oceans. Kooiman is sort of a good touchstone if you want the go-to definition. And essentially, this defines governance systems as composed of three parts: the formal and informal rules, the actual systems or the processes themselves, and then these actor networks. So the take home is that there was, I don't know what the historical timeline is, but there was sort of this growing feeling that government alone was failing to govern in the way that their people electoral wanted them to. So governance is much bigger than government. It recognizes the critical role of government itself, but it also recognizes the inclusion of many other stakeholders and these sort of informal rules as well. So it's sort of the big catch-all. So then what does this look like for us, and what does science contribute to marine governance? For that, I went to a few of our sponsors for this week's event, and I looked at their mission statement, and they're asking for science from us. So for example, NOAA's is responsible for the stewardship of the nation's oceans, resources, and their habitat. We provide vital services for the nation, and it's all backed by sound science. So that's right there on the front page in the mission statement. If we look at KIOST, which is another one of ours, the Korean Institute for Oceanographic something I can't remember, they also aim to discover new scientific knowledge about the ocean for the benefit of people. So these big sort of governance bodies are asking for science from us. So then when I was preparing for this, Chris said it well, that this governance thing is quite messy, and this lecture for me was the most difficult one to prepare because it's so big and it's so challenging.
That's why I gave it.
Yeah, thank you. That's why I pawned half of it off on Rashid, and he'll be taking all the questions. So they want science from us, so what's our role? So again, trying to make it simplified for my brain, I think it kind of looks like this. Our job is to generate evidence, and that evidence is then used to inform their decision making. And I think we're kind of doing research in a cool time because we're getting more sort of criteria and structure around what this can most effectively look like. So in about the 70s, correct me if it might have been earlier than that, they established guidelines for what best available science would look like to inform structured decision making. And then very excitingly for us social scientists in the room, 30 years later, we've caught up, and we're now, last year, groups of colleagues were publishing on what criteria for best available social science might look like. And just briefly, these usually contain three elements. So a definition about what constitutes science, a consideration of what science is available, and then an objective way to evaluate scientific evidence. And these criteria change depending on which organization is using them. But really interestingly is a lot of these marine governance laws actually require that you make use of the best available science. So no small task for us, but what we're trying to do is do really great research that provides evidence that then will be used to inform decision making. So, apologies to Beth and Ingrid. I've really bastardized your figure here. You won't even recognize it, but this is from your human behavior paper. So I use this as a bit of a structure for my brain because we're now recognizing how interdisciplinary this kind of research and evidence needs to be. And I was really, Laurent's example on the first day about how the open ocean oxygen people don't talk to the coastal oxygen people, that's rampant in marine governance as well. So a very dear colleague, Rosemary Omer, who's a senior scientist in Canada, she used to sit in Ottawa, which is where our government is based. And in the building that worked on fisheries scientists, on one floor, there were the fisheries scientists who were, during the cod moratorium in Newfoundland, were delegating cuts to what people were actually allowed to do and essentially cutting people's jobs. On the floor below, there was the social welfare office that was then giving out welfare to people whose jobs were being cut. And the two floors didn't actually speak, so these things weren't being lined up. So I'm finding it encouraging to be at events like this and more increasing, I guess, normalization of the interdisciplinary nature of this kind of data that we're generating to govern the oceans. So this figure in the paper is originally designed to point out points of uncertainty in the management system. I'm going to use it just to quickly highlight points of data generation. And the cool thing is everybody who's here in the room is generating research and data that could be used to inform decision making at some point around this circle. So traditionally, most of the evidence for marine governance came from this half of the circle, which is really about the ecology and the resource state itself. My dad is a retired fisheries scientist who was trained at UBC and worked for DFO, and he was a hardcore quantitative ecologist who didn't think social science was a real science. I've convinced him otherwise. But this is traditionally where our data came from. So these will be familiar debates to many of us in the room, but our data used to largely be based on assessment of the stocks. How well is a particular fish stock doing? And there are contentious debates, which I will not get into, about whether that's best generated from catch data or landings data, which is normally reported at national scales or different scales, or ecological surveys. And you can get very different evaluations of how the stock is doing based on which and so this is one of my go-to resources, which I give you as a place to go and read about these if you want to. But there are very heated and long-term debates about which type of data is the most useful. And I love Laurent's take on this. There are disagreements between the way we do this, but we generate data and we have these conversations. So this, I'm not an expert in it, but this is a go-to resource that summarizes some of these and key papers within the debates. So that's sort of the most common way to assess stocks is those catch data or stock assessments. An interesting one from my perspective is the social scientists are saying, look, we know that a lot of fish is consumed directly at the household scale, or it's traded informally and it never makes it into catch statistics. So if we want to actually look at how many fish there are, maybe we can come in from the other direction and look at how much fish is being consumed at the household scale. So there was a big study that came out that, it's insane. They have data from more than 500,000, so 500,000 households in countries around the world. And when they compare that data, which is what they get in the bluefish, they're pointing out that we're missing large chunks of how much fish is actually being caught when we're just looking at landings data. Another really cool one, which we had a really good introduction to this morning through Priscilla's presentation, was a lot of times there's just not enough data available to us to actually provide evidence. So this top graph is the landings data as reported to the FAO at the national scale for Mozambique. So anyone who's familiar with landings data will know that something really weird is happening in 2003. Does anyone know or want to guess at why we got this massive jump? Not directly.
the effort to count to a point?
That's exactly right. So you guys know from yesterday, Mozambique's had this really long and violent civil war, and then before that, independence war. So the gap here is in 2003, they started recording small-scale catches. And so small-scale catches in Mozambique are almost 80 or 90% of the total catch, and we just don't have data for it before 2003. So one of the things that I did while I was there, and Priscilla nicely walked us through this, is I did historical interviews with old fishermen, and we tried to reconstruct some of what those catches might look like. So this is all to say that there's lots of different ways we generate data about how the stock is doing, which then can be used to inform management decisions about how much yield might be sustainable. So moving to the good side of the circle, or the social side, there's lots of ways that we generate data through our research that then can be used to inform management. So this is a really neat example which got quite a bit of attention, just came out by David Gill, this paper on marine protected areas. And essentially looking at a global survey, the light blue dots on the map here are where they've found that there's actually inadequate capacity to run that particular park. So that speaks to the prevalence of paper parks, and they essentially point out that if we want marine protected areas to be effective at protecting the resources inside of them, we need to invest in capacity building and better resource these MPAs in all the light blue dot areas. So that's a really neat management lever that this kind of paper speaks to. Another cool way that we are generating data, which can be used for management, is we can challenge some of these prevalent norms that often are quite influential in policy, even if they're not backed by empirical evidence. So throughout the Pacific, traditionally managed areas, whether you call it a locally managed marine area or a co-management system or a customary marine tenure system, they're very common, and they're very beneficial for many reasons. They're socially quite acceptable, they're easier to implement in remote communities that are all over the place, and there's this sort of underlying assumption that they're good for the resource too. So sorry for those of you who are familiar, but let me just explain them because they're so cool. They're like legendary stuff. So in the Pacific, communities generally controlled the reef that was just in front of their village, so they could see it and they would decide who had access to it. And one of the most effective ways that they managed that was to use a traditional taboo or tambu. And that palm frond there marks this reef is off limits, nobody can fish there. And just interestingly, that's where the word taboo comes from in the English language. When James Cook was sailing throughout the Pacific, he got that word tambu from the Melanesian people. So they close a reef, but then periodically harvested means that every once in a while, usually the chief or perhaps a collective body of elders decides we're going to lift that tambu and fish that area. And they usually coincide with important cultural events, so perhaps around a Christmas or a gathering that needs food, or more recently, if there's a need for money. So usually just before school starts and people need fees for money for school fees, they'll lift that tambu. They often only open it for a few days or a few weeks at a time, and then they close the reef again. So there's an assumption that that's quite good for sustaining the resource. But colleagues of mine from JCU and from World Fish actually went out and measured that using biomass indicators, and what they found is that the very short, maybe 2 or 3 week harvests are very intensely fished, and so for sedentary or slow growing species, they're actually not sustainable, even though they were closed throughout most of the year. So that's another kind of piece of data that's useful for policymakers or for management as we're designing these co-management systems and tweaking them accordingly. I think this might be my last example. But we're also, this is one of my pieces of work, and Priscilla talked about this quite a bit this morning, but sometimes these things work great and sometimes they don't work so well, and trying to figure out why and what those differences are is a really cool area of research. So I worked with communities, 5 communities in Solomon Islands that have been doing community-based management for a 10-year period. And 2 of them we deemed as successful. And so we talked about this a little bit this morning, but for success metrics, that's a whole can of worms itself. We used Eleanor Ostrom's social ecological systems framework to look at success on a social and ecological outcome metrics. So we looked at, number one, was the management system sustained 10 years later? Was it still in place? Number two, did the people in that community perceive it as an equitable process? And number three, did we actually see improvements in biomass within those community managed areas? So we found that 2 out of 5 of them met those 3 criteria, whereas the other 3 didn't. And so then we did interviews, we did focus groups, and we looked at this long data set we had of this 10-year co-management project, and we came up with reasons that these 3 were not as effective. And they're pretty familiar to us, but they're things like, was information being shared with the community, or did they not know what was going on? Were they actually merging with some of the traditional rules, or were they trying to be quite top-down and saying, you guys just can't fish here anymore? Was there strong leadership? So were people in the community really championing the process? And really cool, in those strong leadership, the 2 cases, the chiefs themselves were actually leading resource monitoring. And when people could swim transects of the reef and see better quality ecosystems in there, they were motivated to keep with the process. So this kind of data is social science. You know, it wasn't considered. My dad would have balked at it in the 70s that this didn't belong in marine governance, but it can be used to inform how we tailor these systems and make them as effective as we can for both social and ecological objectives. So if you're really ambitious and you're Rashid, you try and get all of this in one. So this is a new framework that came out, and you know, there's many frameworks, so this is just an example. But there are ways that we can try and capture many of these elements at one time. So this is a framework to comprehensively evaluate these 4 pillars of a particular management system, and then try and inform how we manage it. So looking at ecological indicators, looking at economic indicators, social and cultural and institutional. So those are some of the ways that we as scientists can directly inform, or indirectly. That's a debate for Chris to resolve. So as the last slide before we can open it up for discussion, I wanted to bring out sort of an elephant in the room, and I'm afraid to go here because I don't have the answer, but we're living in a very strange time for science, you know? So post-truth was voted in as the word of the year in 2016, and that means that we've now come to an era where facts are less important than emotional appeals. And it's actually worse than that. You know, not only are we living in this strange place where alternative facts rule and you can just make up anything and put it on Twitter and it's the law, we're also actively being attacked as scientists. So in the Canadian system, for 10 years, we were under a government that actively cut our research programs, and they call it the death of evidence. Yeah, so I don't have the resolution for that, but I'm very encouraged to hear all of my lecturers here saying, now more than ever, we need to be sharing our science, and we need to be very truthful about communicating and careful how we navigate that. So I'm hoping that that is a great handover to Chris on how we improve knowledge exchange. But yeah, I'd just like to highlight that because that's a big one that we're dealing with, and it's different. We're in a different landscape as scientists that we have been before. So that's all I have.
We have a few minutes for discussion. Oh, no.